Hey students, I got a request to make a video solution for 41. So let me give it a try. So as you're working on these, let's see how 41 pans out here. It says each capacitor in the combination shown in figure 41 has a breakdown voltage of 15 volts. All right, let me draw the picture that they have. They have first a set of capacitors in parallel. It's a 20 microfarad and another 20 microfarad. Those come together, so those two are in parallel. And then that group is in series with a 10 microfarad. And then that group, or that one, then continues on into a group of 20 also. That is in parallel, so this is just like the first group, it looks like. And, of course, they are saying you cannot have more than 15 volts on a given capacitor. Now, what would that mean for the total voltage across here? So let me just kind of make a simplified version, or what we call an equivalent circuit of this. Let me take these two that are in parallel, so we add them. That's 40, that's still a 10, and then this is a 40. And so this is the equivalent circuit. And of course, what they are saying here is you can't have more than 15 on any one capacitor. Okay, now note that this here is in series. And so if we were to connect a power supply, call it V, its voltage would be spread out over this one, and this one. So if any one of these can at least handle 15, that means the sum of these three is going to be greater than 15. So I'll just say that, okay, it says, how does it say, what is the breakdown voltage of the combination? So you could apply more than 15 to this combination. You just can't have 15 more than to any one of those. Now, here I think is one way of doing it, not the only way, but it's the way that kind of comes to my mind first, is since we know they're in series, they have the same charge on them. Charge, and remember, maybe I'll put it up here, capacitance is charge over voltage. So the charge is the capacitance times the voltage. Okay, why do I say that? Well, again, I say that because maybe if we call this number 1 and this number 2 and this number 3, capacitor 1 times its voltage 1 would have to be the same as capacitor 2 times its voltage, number 2, which would have to be the same as capacitance 3 times its voltage, 3. So, of course, you can see that 3 and 1 are really kind of the same thing. So I really probably just need to have a discussion between 1 and 2 here, not really involving 3. As you can see, 3 and 1 have the same capacitance, 40, and so they're going to have the same voltage. Okay? But again, this is really where the discussion is right here, because these have to be equal to each other. So maybe if I look at this first set of equations, number 1, and compare it to number 2, notice that number 2 has a lower capacitance than number 1. And so for the product to be the same, it's going to have a higher voltage than number 1. See, what I'm after is, of these three, which one is going to have the highest voltage? And, of course, 1 and 3 are going to be the same, and hopefully this argument here that number 2 is going to have the highest voltage. So it'll always have the highest voltage because it has the smallest capacitance. The two together have to be the charge. So what's going to happen then is we need to limit voltage number 2 to 15 volts. And if we do that, the voltage on number 1, and for that matter on number 3, are the same, are going to be under 15 volts. But if we put any more voltage on there, that's when we get too much on number 2. So let's operate from the idea that we are going to increase this voltage right here up to some value until we get to the maximum of one of the capacitors, and it would be this 10 one, when it gets to 15. So if I did that, I could also tell you how much charge is on number 2, which, as I said earlier, is the same as the charge on number 1, which is the same on the charge as number 3, since this equivalent one is all in series. So the capacitance of number 2 is 10 microfarads. And we're going to then say, okay, what if we charge it up to 15 volts, or put enough voltage here so that that one is 15. So this is 150 microcoulombs of charge. Now, I'm going to use that to say, okay, so what would the voltage be on number 1, which, by the way, would be the same as number 3. So I'm going to write voltage on number 1 here would be the charge on number 1 divided by the capacitance of number 1. Now, I'll come back up here. The charge on number 1 is this 150 microfarads. And the capacitance of this equivalent one, which these two have the same, okay, really, because that's the real circuit up here. We got to make sure that one's not greater. But these two are in parallel. They have the same voltage, and they have the same as this equivalent. And so this would be 150, so 15 divided by 4 is 3.75 volts. Okay, so again, if we were to hook something up, this voltage right here on this one is 3.75. This one has come up to 15, and this one's identical. Number 3 is identical to number 1. So the voltage across here is what? 15. 3 and 3 make 6. 3/4 and 3/4 makes 1 1.5. So 11, 12, carry 1. So 22.5 volts. So if we were to apply 22.5 volts to this whole series, and maybe we started at less. So we start at 0, and we have a little dial, and we crank it up, and it gets more and 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 more. Okay? As we get more and more and more, eventually this one right here gets to the 15, and that's where we better stop. And when it's at the 15, these are at 3 3/4 each for a total of 22.5. So that's the maximum on this circuit. Hopefully that helped.